So here's something that drove me a little crazy when I was working in this industry. Everybody says hydrogen is the fuel of the future. Clean, weightless, burns to water, the whole pitch. But almost nobody stops to ask the one question that actually matters. Which hydrogen? And it's almost a trick question because the gas itself is identical no matter which color you're sold. The hydrogen that comes out of a coal plant is the exact same molecule as the hydrogen from a solar-powered electrolyzer. So those colors everyone throws around, gray, blue, green, turquoise, pink, white, none of them describe the gas at all. They describe how it was made. The color is just a marketing word for the recipe. And the recipes could not be more different, because one way of making it is basically free and filthy, and another is genuinely clean and stupidly expensive. And the whole game is figuring out which colors actually close the gap. I spent over a decade taking first-of-a-kind energy tech from a lab result to something a bank will actually finance, and hydrogen was right in the middle of my world, so let me just give you the verdict up front. Most of the rainbow is marketing. Today, really only two colors are honest, near-term bets. One of them is a genuine wild card that could change everything or amount to nothing, and the part nobody tells you is that the subsidies, not the chemistry, quietly decide all of it. Stick to the end, and you'll walk out with two numbers that let you cut through any hydrogen headline for the next decade, a cost number and a carbon number, and you'll know exactly which color is which. Okay, so why do we even color code a colorless gas? Because hydrogen doesn't exist. Lying around in a tank somewhere, you have to make it, and making it is where all the carbon and all the cost hide. So the entire rainbow really collapses down to just two numbers, and these are the two I want you to hold on to the whole way through. Number one is dollars per kilogram. That's the cost. Number two is kilograms of carbon dioxide per kilogram of hydrogen. That's how dirty it was to make. Every color is just a different spot on that map. Cost on one axis and carbon on the other. And once you see it that way, the marketing kind of falls apart in your hands. So let's actually walk the rainbow, cheapest and dirtiest first. Start with gray, because gray is what basically all hydrogen is right now. You take natural gas, you blast it with steam, and you strip the hydrogen off the methane. It's a 100-year-old industrial process, it's cheap, it works, and it is everywhere. Global hydrogen demand hit about 97 million tons in 2023, and the inconvenient truth is that almost all of it is made from unabated fossil fuels. So when somebody tells you we already have a hydrogen economy, we do, and it's gray. Gray costs somewhere around $1 to $2 a kilogram, which is dirt cheap. And here's the catch, the number that defines this whole episode. Making 1 kilogram of gray hydrogen throws off roughly 9 to 12 kilograms of carbon dioxide. Think about that ratio. The thing we're selling as the clean fuel of the future, in its current form, emits about 10 times its own weight in carbon dioxide. Its dirtier cousin, brown hydrogen, that's hydrogen cracked out of coal, and it's big in China, is even worse, up around 18 to 20. So that's your baseline. Cheap, filthy, and it's the bar every clean color has to beat. Now, let's see who can actually beat it. First contender is blue. Blue is just gray with a catch. You take that same natural gas process and you bolt carbon capture onto the back end to grab the carbon dioxide before it hits the sky. On paper, it's beautiful. Same cheap gas minus the emissions. It runs around $2 to $3 a kilogram, so a bit pricier than gray, but not crazy. And this is the one the oil and gas majors love, because it keeps natural gas in the game. But blue has two problems that the brochures skate right past. and you need both numbers. The first is the capture rate. To call this clean, you need to grab well over 90% of the carbon, and a lot of real-world plants capture nowhere near that. The second one is sneakier, and it's methane leakage. Natural gas is methane, and methane leaks on its way to the plant from wells and pipelines, and methane is a brutal greenhouse gas in its own right. There's a famous 2021 study by Howarth and Jacobson that ran the leakage at 1 to 4% and concluded that blue hydrogen's full life cycle footprint can actually be worse than just burning the gas. So blue is only a real bet if, and it's a big if, the capture is genuinely high and the gas supply is genuinely tight. Honest blue is a decent bridge. Dishonest blue is a fossil lifeline wearing a clean costume. Next is turquoise, and this one is genuinely clever. Same starting material, natural gas, but instead of burning the carbon, you crack the methane apart with heat, so the hydrogen comes off as gas, and the carbon comes out as a solid, literally a black powder, carbon black. The stuff in tires and ink. And because the carbon never becomes carbon dioxide, there's no gas to capture and bury, you just sweep up the solid. Here's the twist that makes or breaks it. That black powder is a product you can sell. The base case economics land turquoise near $1 a kilogram of hydrogen, but only if you can sell the carbon. And there's the rub, because if everyone starts cracking methane to make hydrogen, you'd flood the carbon black market and crash the very price the whole model depends on. It's real though. A company called Monolith has been running a commercial scale plant in Nebraska since 2020, pumping out a couple thousand tons of hydrogen and around 14,000 tons of carbon black a year. So turquoise isn't science fiction. It's a does the byproduct math hold up at scale question, and that's exactly the kind of thing we love to tear apart. Now the headliner. Green. This is the one everybody pictures when they hear clean hydrogen. You take water and you split it with electricity in a machine called an electrolyzer, and if that electricity comes from solar or wind, the carbon is basically zero. 2 atoms of hydrogen, 1 of oxygen, pull them apart with clean power, done. It's the dream, and unlike the others, the dream is real. The problem is the price tag. Green runs roughly $3 to $6 a kilogram today, and the IEA has seen it as high as $12 depending on where you are. So at best, it's 3 times the cost of gray, at worst more like 6. And here's why. The single most important fact about green hydrogen. Electricity is 55 to 70% of the cost. Green hydrogen is basically your electricity bill wearing a lab coat. Which means green isn't really one number. It's a bet on cheap, clean power. And where electricity is cheap and clean, green has a real shot. And where it isn't, green is a very expensive way to make a molecule you could have bought for $1.50. And one more catch people miss. Green is only green if the grid is. Plug an electrolyzer into a coal-heavy grid and you can make hydrogen that's dirtier than gray, which, as we'll see, is exactly why the rules got so strict. 2 quick ones before the money. Pink is just green's nuclear cousin, same water splitting, but the electricity comes from a reactor instead of a solar farm. The clever part is that a reactor runs flat out around the clock, so your expensive electrolyzer is actually working most of the time instead of sitting idle when the sun's down, and that utilization quietly improves the economics. Pink basically rides whatever happens with nuclear, so it's a watch. And then there's the wild one, white hydrogen, also called gold or natural hydrogen. The twist is, you don't make this one at all. It's just down there, made by the planet, pooling in the ground like oil and gas, and you drill for it. Sounds like a fairy tale, except there's a village in Mali called Borakibugu that has literally been running on a natural hydrogen well for years, after a driller hit it by accident decades ago, and it caught fire. Researchers found the reservoir even seems to refill itself. And in 2023, a big find got announced under the Lorraine region of France. If white hydrogen is real at scale, it's potentially clean and cheap straight out of the ground, which would blow up this entire ranking. But right now, it's almost pure exploration. Nobody's proven. You can pull it out economically at scale, so anyone quoting you a price is guessing. It's the wild card, enormous if true, unproven today. Okay, so we've got our colors on the cost and carbon map. Here's the part that actually decides the winners, and it's the part the engineering crowd always underrates, the subsidies. Because none of these clean colors beat Gray's $1.50 on cost alone, not yet. So governments are paying the difference, and how they pay it reshuffles the whole board. Start with the big one, the US Clean Hydrogen Tax Credit, called 45V. It pays up to $3 a kilogram, which is enough to make green flat-out competitive with gray. But here's the key design choice. It's tiered by how clean your hydrogen actually is over its full life cycle. To get the full $3, you have to come in under about 0.45 kilograms of carbon dioxide per kilogram of hydrogen. And if you're above 4 kilograms, you get nothing at all. Hold on to that 4 kilogram line, because that's the gate. Gray at 10 and brown at 18 aren't even close. Honest green and pink sail under it. Blue has to fight for it, depending on its real capture and leakage. The carbon number literally decides who gets paid. And there's a sting in the tail for green specifically. The final US rules say that if you're running off the grid, you have to prove your clean power is genuinely additional, meaning new clean generation matched hour by hour in your own region. They call it the 3 pillars, and it's there to stop people from buying a cheap clean energy certificate while actually running on coal. It makes the credit honest, and it makes it harder to earn. And one more thing that proves my whole point about policy running the show. In 2025, a budget bill moved up the deadline, so to even qualify for 45V, you now have to start building before 2028. A single rule change just rescored every hydrogen project in America. That's the lesson. The chemistry barely moved, but the economics flipped overnight. And Canada runs the same play through a different door. Instead of paying per kilogram, Ottawa hands back 15 to 40% of a project's capital cost, tiered by the exact same carbon math. Under 0.75 kilograms, you get the full 40. At 4 kilograms or more, you get nothing. Same 4 kilogram gate, different currency. They even folded methane pyrolysis in, so Turquoise gets paid north of the border too, and carbon capture gear has its own 50% credit, which quietly backs blue. And the pen moves here as well, because in May of 2026, Ottawa redrew its industrial carbon price curve from a line pointing at $170 a ton by 2030 down to about $115, and every capture project in the country got repriced by one announcement. Quickly, the rest of the money map. There's 45Q, which pays $85 a ton to bury carbon dioxide, and that one specifically props up blue. Europe runs it differently. The EU Hydrogen Bank just auctions a fixed subsidy per kilogram, and the first auction cleared at around 50 cents a kilo of European money, which tells you roughly what the cheapest clean hydrogen in Europe needs to pencil. Europe's also got a carbon border tariff now called CBAM that taxes the carbon in imported hydrogen, so dirty imports lose their price edge. And China is playing a completely different game. Instead of subsidizing the hydrogen, they're winning the machines, because Chinese electrolyzers run about a quarter the price of Western ones. So the West is subsidizing demand while China is crushing the cost of the hardware. Keep an eye on that one. So let's actually stamp the board. 5 honest verdicts. Green is a real bet. It's the headline color, Genuinely clean, expensive today, but it's the one the money and the policy are actually built around, and it works wherever clean power is cheap. Blue is a real bet, conditionally, a legitimate bridge if it's honest about capture and leakage, and a fossil lifeline if it isn't, so watch the capture rate like a hawk. Turquoise is a watch. Clever, genuinely lower carbon, real hardware in the ground, but the whole thing lives or dies on selling that solid carbon. Pink is a watch, quietly sensible, and it rides the nuclear wave. White is the wild card. Not yet. It could rewrite everything, or it could be a mirage, and we won't know for a few years. And gray and brown, that's the incumbent, cheap and filthy, the thing every other color is trying to kill, and clean is the one thing it is not. So here's the one thing I want you to keep, the two numbers. Next time anyone pitches you hydrogen, ask exactly two questions. What does it cost per kilogram, and how many kilograms of carbon did it take to make 1 kilogram of the stuff? Cost and carbon. Because the color is marketing, but those two numbers are physics and money, and they don't lie. And remember the kicker. The cheapest clean color still can't beat dirty gray without a subsidy, which means a politician with a pen can re-rank this entire industry in an afternoon. The molecule is simple. It's the recipe and the rules around the recipe that decide whether any of this is a real bet. And that's the map. Everything I just walked you through, the verdict and every number behind it, that's yours, free. That's the show. But if you want the whole thing, the full research report, plus the financial model, the actual spreadsheet where you can swap in your own power prices and carbon costs and run any color yourself, I've packaged it all up at bankable.show, and it's free. I just ask you, tell me what you're working on, so I know who's out there and what to dig into next. And that's where you come in, because this was the overview, and now we go deep on one color at a time. So tell me which one. There's a poll up in the community tab, green, blue, turquoise, or white, or just write your pick in the comments. Whichever one the most of you pick is the next full tier down, model and all. Subscribe so you don't miss it. This is Bankable. Scored verdicts, cited numbers,